Okay, so this is almost identical to the previous problem, but I'm going to present it a different way or show you a different way. Or the so calculating annuity present value. That's all we're talking about is a series of identical payments. So the investment offers to pay $1,500 a year for 15 years, with the first payment occurring 1 year from now. Required rate of return is 7%. What is the value of the investment? So we can use a formula to do this calculation. The present value is equal to it's the payment, the $5,200. This is the present value of annuity formula. So one minus one divided by one plus the rate. In this case, it's 7%, so it's 1.07, and then that would be the 15th power. And then then you divide by 0.07, and you should get 47,361.20. So a lot of times you'll see the formula where the 07, this 0.07 is over here. Now, if it's either way is acceptable, the solves the problem correctly. If we're going to do this on the calculator, so n would be 15 IY 7, PV is 0, payment is 5,200. Recall in the previous problem we used the cash flow function on the calculator, but if the cash flow is constant, we can use the time value money case. And then I'm sorry, we're computing PV. Future value is 0. So, and then we compute PV and should get $47,361.20. So, if next part of the question, what would be the value if payments occurred over 40 years, 75 years, forever? So, the forever means it's a console, perpetuity, so forth. But let's do the here for 40 years. All you're going to do, the only change would be your 15 becomes 40. And on your calculator, you're going to change in from 40, that'd be 240, and then compute PV. And the the length of time increased, the number of payments increased, and the rate didn't. So the value's got to go up. So this is $69,324.89. So, again, can't stress how important it is to think about your answers logically. So if for example, if you added payments or increased payments on a present value calculation, the value or increase the size of payments, the value has to go up. So then 75 years, so n is just 75, and then compute PV. Got to go up again, $73,821.07. Notice that the increase is tapering off here. The value of these payments is the payments in the first 15 years are more valuable than the payments in the second 15 years, and so on, the third, fourth, and so forth. So the sooner is always better than later. So for a perpetuity, for forever, so it'd be 5,200 divided by 0.07, and that's $74,285.70. $74,285.70. There we go. It's almost legible now. The notice here to from 75 years to forever. Added $500 and change, $564 or something of that nature. Again, the value of those payments beyond 75 years isn't terribly valuable.